Here we have a quadratic function because it's a second degree function. It's not linear, which would mean to the first power. And we know that it is okay to look at the answer format to get an idea of what we're trying to achieve here. And notice they're essentially all, except for option D, which is a little bit different, but they're basically in what we call vertex form. Now, in case you forget what that is, we could go to our program function, which we can go to alpha cosine to get right to the f's, and then we'll go ahead and look at quadratic. And then there's these three different forms of a quadratic function. And the format A, B, and C are in, and D kind of looks like at the beginning, is vertex form. So how do we get it to go from standard form, which is what we have in our initial problem, to vertex form? Well, that process is called completing the square. So we'll go to our program, completing the square, which you could just type 0, or you could scroll down to it. And this is one of those programs that has multiple options, in this case, 2 options of what we could do. And we're taking a quadratic function. We'll look at a circle function later, but this one's a quadratic, so we'll press option 1, so just press enter, and we'll type in those coefficients, 2, 4, and 3. And notice it shows us the form of vertex form, and it also gives us those coefficients. So we'll put the 2 in place of a. Now, something important to notice, it has x minus h, which means whatever h is, you essentially put the opposite here. So it's x plus 1 squared, whereas here, because it says plus k, whatever the k value is, you just put it. If it's a positive, you keep it positive. If it were negative, you'd keep it negative. And then we can go ahead and look at which answer option matches what we have, and that's answer option A. And remember, you got this.